All right. Good evening, everyone. Welcome to today's edition. So today we'll be looking at uh, today we are going to be looking at differential equations. So that's what we'll look at today. We'll look at differential equations. Okay. So for differential equation is divided into two. So we have the ordinary and we have the partial. Okay. So basically, ordinary is what we are going to be looking at today. That is the ordinary differential equation. Then partial differential equation is a topic to discuss on another day. When you hear differential equation, what comes to your mind? Differential equation is one of the engineering, very important engineering topic that is used to solve engineering problems. For example, to solve a differential equation, we have to find the functions to which the equation is true. This means that we have to manipulate the equation so as to eliminate all derivatives and leave the relationship between y and x. So that's basically what differential equation is all about. We are trying to we are trying to build a model for a particular something, and and at that point you try to eliminate, when you create a formula or an equation for it, then you eliminate all the derivative in the equation. Then after you've done the elimination, then you know the relationship to be in terms of x and y. So once you've done that, what you simply do is just differential equation. So let's go deeply into it. In differential equation, there are different methods of solving differential equations. So there are different methods. So we'll be looking at it one step after the other. Okay. So the first thing we are going to look at is we have the direct integration method. So for the we are not going to talk about the direct integration method, and the reason is because it's very simple and very easy. For example, let's say that you have your dy equals to dy dx equals to, let's say, x squared, for example. So this is just an example of direct integration. So what you simply do is that you just cross multiply. So here you have dy dx is equals to x squared dx. Oh, sorry. So you have dy is equals to x squared dx. So what you do is you integrate. In integration, you are going to have, if you integrate dy, it's going to be y. And if you integrate x squared, it's going to be x2 plus 1 over 2 plus 1. I know you are familiar with it, then plus c. Y will be equals to x raised to the power of 3 over 3 plus c. This is direct integration. It's very easy. So today we'll be looking at when you have a problem that you have to separate variables. That's what we'll look at today. When you have a problem that you have to separate variables. Okay. So it's not every time that the problem will come in form of direct, that it's not going to have y. So there are times that the problem will come in a way that is going to have y. So now let's start by separating variable. By separating variables. By separating variables. Okay, so let's take an example. Let's say that you have to solve dy dx equal to 2x over y plus 1. You have to solve this kind of equation. So the first thing you do is that you separate, according to the word separating variables. We have two variables in this equation. We have variable x and y. So you take y to one side of the equation and you take x to the other side of the equation. And how do you do that? Now look at this. We have, this is 2x over y plus 1. So this y plus 1, this y plus 1 is supposed to be here. So you can take it to the other side. So if you cross to the other side, or you just simply cross multiply, then you have y plus 1 in the y, which is equal to, then this dx, we have to cross to this side, so you have 2x dx. So you just simply say you cross multiply. Then we are going to have that y plus 1, then dy equals to 2x dx. So at this point, you integrate. That's what we are going to do. So we are going to integrate, and upon integration, if you integrate y plus 1 dy, now you can separate it. It's very simple. You can simply say that integral of y dy plus integral of 1 dy, or just simply say dy, which is equal to integral of, you take out 2 as a constant, x dx. So if you integrate y, it's going to be y squared over 2. Then plus if you integrate dy, we are going to have y. And if you integrate x, you are going to have x squared over 2. These two will remove these two, then plus c. Therefore, we have y over 2 squared plus y equals to x squared plus c. So this is the relationship that we are talking about. Okay? So this is the relationship between the y and the x. Let's move further. Okay, let's say that you have the y dx, which is equals to 1 plus x, then into 1 plus y. If you have something like this, what you do is that you, as you know, you separate the variables. Okay, so let's separate the variables. We have x plus 1 here. Let's just leave x plus 1 here. And let's take this 1 plus y. Let's take it to the side of y. So if you do that, if here is at the numerator here, then once you get to this side, it's going to be the denominator. So here is going to be the y into 1 plus y, then which is equals to 1 plus x into this, the dx is on the denominator on the right hand side. Then it will become the numerator. It becomes the numerator on the right hand side. So here you have 1 over 1 plus y. The y is equals to 1 plus x dx. So the next thing you do is integration. So on integration now, this type of function in integration, if you are good at integrating, this type of function in integration is simply a lim function. Okay. So what you have is 1 over 1 minus plus 1. Now you check the denominator. If you differentiate the denominator of this value, if it gives you the numerator, then you know that the integration is simply the lim of the denominator. Okay, let's do it. Now, if you differentiate 1 plus y, it's going to give you 1. So when you notice that 1 is the same thing as what you have in the numerator. So you simply say that the integration of 1 over 1 plus y is the same as what? As the 1 plus y, then which is equals to the difference. The integration of 1 is x, and the differentiation of x is x squared over 2, then plus c. So that's all. This is simply the relationship between x and y. So it's as simple and easy as that. Okay, let's take another example. Let's say that you have, so let's say that you have y dx is equals to y squared plus xy squared divided by x squared y minus x squared. See, something like this. So let's see if there's a way out for this. So you notice that here you can simply factorize. So let's factorize. We're going to have y squared into 1 plus x, close the bracket, then over. This is going to be x squared into y minus 1. Can you see now? So here it is easy for you to separate them. In separating them, you can have your dy here. And this y plus 1 is at the numerator. It's at the denominator here. So you take it to the numerator. So you can have y minus 1, then over. Also, this y squared is the numerator here, which will become denominator here. Okay, then what else again? Which is equals to 1 plus x to remain there. Then this is going to be the x, then divided by that's x squared. Okay, now let's go further. Okay, so all right, so we can have that y minus 1 over y squared dy is equals to 1 plus x over x squared x. All right, now we can simply say that y over y squared minus 1 over y squared dy is equals to 1 over x squared plus x over x squared dy dx rather. Now here you are going to have 1 over y minus 1 over y squared then dy equals to 1 over x squared plus 1 over x dx. Now when you integrate this, let's integrate now. At this point, let's integrate. So by integrating, you discover that if you integrate 1 over y, it's going to be ln y, then minus integration of 1 over y squared should be y raised to the power of minus 2 plus 1 over minus 2 plus 1. Then which is equal to integration of 1 over x squared should be x raised to the power of minus 2 plus 1 also divided by minus 2 plus 1. Then plus integration of 1 over x is ln x, then plus c. Then you have ln y minus y raised to the power of minus 1 over minus 1, right? Then which is equal to x raised to the power of minus 1 over minus 1 plus ln x plus c. Then you can readjust. It's going to give you finally you have ln y. Then because of this minus they will change to plus. The minus at the denominator to so you can have plus. You have y raised of minus 1. Then which is equals to you can say minus x raised to the power of minus 1 then plus ln x plus c. Then finally we can have it as ln y plus 1 over y, which is equals to ln x minus 1 over x plus c. So this is simply the relationship between the x and y that we are looking for. Don't forget that in differential equation, we are just trying to see a relationship between the variables x and y. So what we'll try to do is that we'll eliminate the derivative. So anytime you're given any differential equation, what you're expected to do is that to eliminate the derivative. That's what you're expected to do. So, and there are different methods in which you can use to eliminate those derivatives. So, and one of the methods is using separating the variable. So when you separate the variable, it will be easy for you to eliminate, it's easy for you to eliminate the derivative. Let's take another example. So let's say that you have xy dy dx is equals to x squared plus 1 over that is y plus 1. Okay. So let's separate the variable. I think the variable is separable. So let's separate it. Upon separating this variable, you discover that you have, okay, we are going to have y dy. So it's cool, can leave it like that. Then this y plus 1, then is a numerator here, is a denominator here, so it comes here as denominator, as numerator. You can say y plus 1. Let's just permit it like this. Then you have your x squared plus 1 already here. So you leave it. Then this is x. This x here is a denominator, but to come here as a denominator. And this dx is a denominator here to come here as numerator. So let's arrange it well. We're going to have y into y plus 1, then dy, which is equals to x squared plus 1 over x dx. Okay. Then we can have, if you open that bracket, we'll simply have y squared plus y dy, which is equals to x squared over x plus 1 over x dx. Then we'll have y squared dy, just separate them, plus y dy, okay, which is equals to, that's x dx, because x here 1, x here is x, so you left x, then plus 1 over x dx. So let's integrate now. So integrating. So by the time you integrate, if you integrate y squared, it's going to be y raised to the power of 3 over 3. So just simply add 1 to the power, and also everything, anything you have, you divide it by it. Then plus, also here we are going to have y squared over 2, then which is equals to, as this is going to be x squared over 2, then plus the x plus c. So this is simply the linear the relationship between the x and y variable. Okay, let's take another example so that we can better grasp concept of what we are saying. Okay, so let's say that, okay, let's take this example. Then let's say that we have y tan x, y dx, which is equal to as 4 plus y squared, then sec square x. Okay, look at this. You have y tan x dy dx is equal to y plus y squared sec square x. Okay, let's do this. All right, now let's separate the variables. First of all, this tan x is not supposed to be here, it's supposed to be on this side. This 4 plus y squared is not supposed to be here. Let's rearrange. So we already have our y here. This is supposed to be. Then we can take this 4. But this 4, since it's a numerator here, to come here as the numerator, as 4y squared. And okay. Then we have our dy, our dy will be here. Which is equal to this tan x is not supposed to be here, so to come here as as denominator. Yeah. Then this sec squared will remain, then this dx will come as the denominator. So you can see now we have successfully separated our variables. Okay, then what else we can do? We can say y divided by 4 plus y squared, then everything, so everything raised to the power, sorry, dy, then which is equals to sec square x over next. Okay, let's integrate. Very important. Let's integrate. So upon integration, we have that. Upon integration, we are going to have that. We have now if you integrate y divided by 4 plus y squared, you're going to have, first of all, anytime you are integrating, anytime you're solving integration problem, and you come up with, you end up in fraction, like the integration is a form of fraction. What should come to your mind is, okay, is there a way that, is it possible for me to differentiate the denominator and get the numerator? So if you differentiate the denominator and you get the numerator, then it's very easy. So your answer will just be ln uh, of the denominator. And so that's the name is the natural logarithm. Understand the meaning of the denominator. Okay, so let's see if it's actually possible here. Yeah, let's see if it's possible. Okay, so we have 4 plus y squared. Let's see if we differentiate 4 plus y squared. By differentiating 4 plus y squared, it's called that you have 2y. If you differentiate 4 plus y squared, right? So, but here at the numerator, we have y, which is not the same as 2y. So what we can simply do is that, okay, we can simply say that 1 over 2, so that it will be able to complement, the 2 here, this 2, to be able to eliminate this 2. So 1 over 2, then that is 4 plus y squared. See, that's the integration of this. So this one is the integration of this one. Then look at sec again, sec square x tan x. If you differentiate tan x, of course, the answer is sec x. So what do? So you simply say that if you differentiate tan x and you get sec square, so which means that the integration of sec square x divided by tan x is the same thing as ln what? Ln tan x, then plus what? Plus c. Okay, so at this point, you can simply, cross multiply or multiply everything by 2. So when you multiply everything by 2, you're going to have ln 4 plus y squared, which is equals to 2 ln an x, then plus 2c. Okay, now okay, so anytime you're solving differential equation problem and you end up with something like this is a constant, but now it's having a coefficient. So you can simply make it as, you can simply say put 2c equals to a. Just put it like that, it's fine. Just use it as, put it like that, it's fine. Then you have your new 4 plus y squared equals to 2 x, then plus, or that's a, right? So now, since this one is having a limit, okay, then let's do something that will be of help. Let's do something here very quickly. Okay, so let's do something that is going to help. Let me move here. That will not. Okay, Now we have the 4 plus y squared equals to these two links and x. Don't forget that link is just the same as the natural logarithm, and this two link and x means that two, then the natural logarithm of tan x. That's, you can say 2 log tan x is e. And in logarithm, once you have a number at the back here, of course it automatically comes to the top here. So which is going to give you, that's the log tan square x is e. So which is still the same as you saying, ln tan square x. So we can simply put it as, so instead of writing 2 ln tan x, we can say ln tan square x. Then this is the only this thing we have, so we can simply put this one as ln a. Okay, so that the math will, everything will be balanced. Okay, so once you have that, we're going to have 4 plus y squared equals to, since we have linear, right? So when you have two lane adding to each other, so it becomes multiplication. So it's going to be lane into, that is a tan square x. That's what we have. So this lane will automatically cancel this thing. Then you have 4 plus y squared equals to a tan square x. Then your y squared will be equals to 2. That's a. So it's going to be a tan square x minus 4, kind of. So you can leave it like this. So that is the solution to the problem. So you can see this is the linear relation, or the relationship between the x and y that you need. Okay, this is what you need. Okay, finally, for today, let's take this final example on separating variables. Separating variables, very important. So we'll be building on this, on separating variables. So let's say we have x dy dx now, which is equals to y plus xy. Okay, so this is all we have. And we have to solve. So it's very easy. We separate the variable, right? How do we do that? How do we do that? We have x here, we have x here. So now you notice that here we have x dy dx, which is equals to y into 1 plus x. Can you see that? So it's easy for us to separate. So this dx will come as a numerator, and this y will go as a denominator. This x will come as a denominator. So we are going to have dy y will be equals to 1 plus x dx divided by x. So you see now, we finally separated it. Okay, so what we'll simply do is that we integrate now. Let's integrate. So if you integrate this is the same as integrating 1 over y. So if you integrate 1 over y, you're going to have ln y, then which is equal to, integrating this one, let's separate it first before we integrate. So we're going to have 1 over x dx plus integration of, that's x divided by x should give you 1, right? This is plus. Okay, so we can have ln y. So we have ln y equals to, if you integrate 1 over x, it's going to be ln x, right? Then plus, if you integrate 1, it's going to give you x, right? Then plus what? Plus c. So this is simply the, okay, so we are going to have ln y Okay, so simply let's put it this way for convenience. Now this plane x will come in as minus ln x, which is equal to x plus c. Okay. Now this is the previous example will be, if we check it, this is ln y minus ln x, so it's going to be ln x y. Sorry, x divided by y, because when you have logarithm function being subtracted from each other, it's going to give you division, so it's going to be y over x, then this is equal to x plus c. Don't forget that this thing is same as log x over y base e. So that e will just catapult, or will just shoot up this x plus c. This is e now, so this e will push everything here up to become e raised to the power of x plus c. So we are going to have that y over x is equal to e raised to the power of x plus c. Okay, so we have y over x is equal to e raised to the power of x plus c. Now in indices, this is simply the same as using x e raised to the power of x multiplied by e raised to the power of c, isn't it? Then you can have y over x, which is equal to e raised to the power of x, e raised to the power of x dot e raised to the power of c. So simply put e raised to the power of c as a constant, right? Put it as a. If you do that, we are going to have y. So you're going to have y equals to y over x equals to e raised to the power of x multiplied by a, which will give you a x, right? Then once you cross multiply, you can leave the answer as y over x equals to a ex, or you can simply say y equals to a x e raised to the power of x. So whichever one you want to leave the answer, it's fine. Okay, thank you so much for joining us today. That will be all for today. Thank you. See you tomorrow again, same time.